In today's lesson, we're going to talk about acids and bases. In acids and bases, we're going to learn the following. We're going to learn the differences between the acids and bases. We're going to learn the differences between the weak acid and the strong acid. And we're going to differentiate between the weak base and the strong base. First of all, let's start with acids. Acids are substances that lower the pH. As you can see, the pH of an acid starts from 0 up to 6, where 0 till 3 is the strong acid, and from 4 up to 6 is the weak acid. Then, acids are substances that change the blue litmus paper into red. So if we have an acid and we dump a blue litmus paper, most probably the litmus paper is going to change from blue into red color. Acids in chemical reactions are considered to be proton donors. So in the past papers, when they come and ask you a question, define the acids, they are expecting that you're going to talk about the donation of the proton. So when you write proton donor is a substance that donate proton, you are going to take the mark. So in the past paper, we only concentrate on proton donor, but we don't mention the above points. When it comes to bases, bases are substances that have a little bit high pH. So on the pH scale, it starts from 8 up to 14. From 8 up to 10 is the weak base, and from 11 up to 14 is a strong base. Base are a substance that change the red litmus paper into blue. So all the bases changes the red litmus paper into blue, and that's an indicator of the presence of base. And in chemical reactions, bases are proton acceptor. So when you have a question asking you to define the base in the past paper or in the exam, the examiner is expecting that you're going to describe the proton acceptance as a property of the base. Then let's move to the reactions of acids. First of all, we need to look at the general equation, then we're going to see an example for each of these equations. We start first with metal and acid. When metal react with an acid, they produce salt and hydrogen. Let's see an example. When magnesium reacts with hydrochloric acid, they produce magnesium chloride plus hydrogen gas. So one of the observations that you're going to see in this reaction is the formation of hydrogen gas bubbles, and this will be an indicator for the reaction between the magnesium and the acid, or the metal and the acid. On the other hand, when metal oxide react with an acid, they produce salt and water. Let's see an example for that. When we have calcium oxide reacts with sulfuric acid, they produce calcium sulfate and water. So as you can see here, the difference between the metal oxide and the metal reaction, that we have oxygen. So oxygen will change the product from hydrogen into water. So an indicator for metal and acid, we have the formation of bubbles of gases, which is not present in the metal oxide case. Third equation is the reaction between metal carbonate and acids. As you can see, when metal carbonate react with an acid, they produce salt, carbon dioxide, and water. So carbon dioxide is a gas, so you're going to see bubbles of gases that comes up out of this reaction. In order to differentiate between the reaction of metal carbonate and metal with acid, you are going to take the gas and start to do different experiments in order to check the presence of each gas. As an example, when you collect the carbon dioxide gas and you pass it on lime water, the lime water is going to change from colorless into milky, and that's an indicator for the presence of carbon dioxide. On the other hand, when we collect the hydrogen gas and we burn it, it makes a squeaky pop sound. So that's an indicator of the presence of hydrogen gas. Let's see an example for the reaction between metal carbonate and acid. When we have potassium carbonate reacts with nitric acid, they produce potassium nitrate, carbon dioxide, and water. Last reaction is the reaction between acids and alkali. When acid react with an alkali, it produces salt and water. An example for that, hydrochloric acid. When it reacts with sodium hydroxide, it gives out sodium chloride plus water. Let's move to the types of oxides. In chemistry, we have 4 different types of oxides that we're going to be exposed in our syllabus. The first type of oxide is called acidic oxide. An acidic oxide is an oxide or substance contain oxygen that act as an acid. Then we have basic oxide, is a substance that contain oxygen that act as a base. Then we have an amphoteric oxide, substance with oxygen that act as acid and base, so it reacts with both acids and base. And at the end we have neutral oxide, a substance contain oxygen that does not react either with acid nor with base. So let's discuss the first one, acidic oxide. As we said, it consists of non-metal plus oxygen, so we need to have a non-metal bonded with oxygen in order to produce acidic oxide. This substance acts as an acid, so we are going to expect that this substance will neutralize a base. And on the other hand, it changes the blue litmus paper into red. So one of the properties for the acidic oxide, that it acts as an acid and neutralize a base. Examples for acidic oxide, we have SO2 and we have SiO2. So as you can see, we have a nonmetal that bonds with oxygen. On the other hand, we have basic oxide. Basic oxide takes place when metal bond with oxygen. When metal bond with oxygen, they act as a base. Perfect. So we expect a basic oxide to neutralize an acid. Basic oxide changes the red litmus paper into blue. Example for that, we have NaOH, CaOH by 2. So as you can see, we have metals bonded with oxygen, and this is one of the properties for basic oxide. Third type of oxide is amphoteric oxide. The amphoteric oxide is a substance that can react with both acids and bases. So here, this oxide, it can react and neutralize an acid, and it can neutralize a base. An example for that, we have zinc oxide and aluminum oxide. Both act as an amphoteric oxides. Please take care, because this part comes in paper 2 in MCQs. They give you different type of oxides and they ask you, please pick the amphoteric oxide. So you mainly focus on aluminum oxide and zinc oxide. As you can see, the aluminum oxide react with the HCl, react with an acid to produce AlCl3 plus H2O. And when we place it in the presence of an alkali or a base, like Al2O3 plus NaOH, it produces NaAlO2 plus H2O. Then at the end we have the neutral oxide. Neutral oxide is a substance that does not react with an acid nor an alkali. So when we place it in the presence of an acid or in the presence of alkali, it does not react at all. Example for that, we have CO N2O plus NO. I hope you have enjoyed the video. See you soon.